We will continue on with Theorem 1014. We will now discuss the case where a tangent and a secant to a circle intersect at an external point. According to the theorem, if we have a circle with points A, B from the intersection of the secant and a point C, which is a point of tangency of a tangent, let's say this is point S out here, then the theorem tells us that angle S, or the measure of angle S, is equal to 1/2 times the measure of arc BC minus the measure of arc AC. In other words, the measure of this external angle is 1/2 this arc minus this arc. Okay, so let's try to approach how we might prove a theorem such as this. Let me redraw the diagram in a slightly different way. We still will have the intersection of a secant and a tangent. Let's take a circle and let's draw a secant intersecting the circle in 2 points. Let's draw a tangent touching the circle at 1 point like that. And let me call this point A, let's call this point B, and let's call this point C. And let's see, what can we derive from this diagram? Well, we don't know any of these angles to start out with, but we could, of course, give them some algebraic names. I'm drawing the chord AB, and I'm going to call this angle A. I'm going to call this angle over here angle B. I'm going to call this angle here angle C. We don't know what their values are, but I'm just giving them names for the moment. Certain facts follow from these names, though. If angle A has a measure of little a, it's an inscribed angle CAB, and it's intercepting this arc. Let's just give this point D as a reference. Inscribed angle CAB is intercepting arc BD, so the measure of arc BD therefore has to be 2 times A, since this has to be half of the intercepted arc. In addition, if you notice, line CB is a tangent, line BA is a chord. We have a previous theorem that tells us that when a chord drawn to the point of tangency of a tangent intersect, that angle is equal to 1/2 the measure of the intercepted arc. So here the intercepted arc is AB, so the measure of AB we know has to be 2B. Okay, so we've already discovered a fair amount of stuff just from our previous our previous knowledge of what angles do and previous theorems. So now we are left with stuff we don't exactly know. This angle, for example, in here, we could call it 180 minus B. It is a supplementary angle to B. So that could get us to redraw the triangle entirely. To make things clear, let's redraw that internal triangle. Now we're calling this angle here, this is 180 minus B. We're calling this angle A. We're calling this angle C. Okay? Now we need to find this external angle here, C, the angle that's external to the triangle. We know that C plus A plus now 180 minus B all add up to 180. That's by the triangle sum theorem. We can subtract 180 from both sides. That gives us C plus A minus B equals 0, or C, if we add B to both sides, we get C plus A equals B. And then if we subtract A from both sides, we get C equals B minus A. So we have this important equality, C equals B minus A. So now we have a term for C. But notice something. Notice that the difference in the measures of the intercepted arcs is AB, measure of AB minus measure of BD is going to be measure of AB minus the measure of BD. Which is equal to 2B minus 2A. So if we take the measure of those intercepted arcs, divide by 2, we then get B minus A. Well, how about that? We found out that C equals B minus A. So therefore we can say that C therefore equals 1/2 of the measure of the intercepted arcs, which would be the measure of AB minus the measure of BD. Well, that was what we needed to prove, so we've now finished proving this part of Theorem 1014.